Good morning, good afternoon, and good evening to wherever you are around the world. I'm absolutely delighted to be here at the A4Q Congress. My name is Debbie Archer, and I have the absolute privilege of inviting Paul Gerrard to speak to you in a moment. Paul will introduce himself and talk to you a little bit about his presentation before he goes on to cover the content. Just want to say, Paul, a huge thank you to you for being here. It's been a privilege working with you. It's a privilege to call you my friend, and I'm really excited to be handing over to you. So, you, Paul.
Okay, are we on? So I'm here today to talk about thinking your way out of big testing problems. And what I'm going to do really is to show some of you for probably the second, third or fourth time what I call a new model for testing, which is a way we think about testing as we test. And the reason for this, the existence of this thing, is it occurred to me that in order to understand the interactions we have with our stakeholders, the developers, with other people in our project teams, you know, when we are actually acting like a tester in a team, we get bogged down with what I call logistics, which is stuff that is really important, but it's nothing to do with testing. It kind of gets in the way. So stuff like documentation and technology gets in the way of the thinking that we have to do as a tester. So having done that some years ago, I think it's about 6 or 7 years old now. So you could say it's not new, but what the hell? What I want to suggest is that if you understand how you think about these testing in general, if you understand how the brain works a little bit, I think it gives you a much better perspective on some of the big problems that we encounter when we are in the real world projects. So I offer it as a different way of thinking about your job. Okay, if that's the way of looking at it. So what I'm going to talk about is I'll describe quickly this new model idea, and it's not very complicated, but it looks a bit complicated when you see the diagram. But actually, it's a straightforward thing, I think. And then I want to talk about 3 particular problems, and there are others, but the first one is like how testers interact with their project teams in a continuous delivery and with collaboration and so on. So I want to talk about continuous delivery a little bit because that's on many people's agendas, but also I want to use that as an example of a process which is, let's say, new. I know it's not new, but let's say it might be new to you. And how you tackle the problem of understanding how you take your testing knowledge and bring it into a different approach. Okay, so it could be that Agile is still new for you. I mean, you might be just going Agile this year, who knows? But I mean, I think in the next year or 2 or 3 years, we'll see variations on Agile and continuous delivery and waterfall, which has not gone away. And if you like, what I want to say is no one does pure continuous delivery. No one does pure Agile. No one does pure waterfall. I mean, everyone does a kind of hybrid. There's obviously a big emphasis on one of those three aspects, but every project is unique, and therefore you need something that is not constrained by other people's thinking. And you have to. This is where I think that the new model might help you. I want to talk about tools and technology briefly, and just suggest that if you understand what testers actually do when they test, that is, you understand what's going through their minds and how they are operating, if you like, you have a much better understanding of what tools can do and what tools cannot do. And so the argument about whether should tools replace testers, I mean, it becomes a very straightforward one. It's not a complicated argument at all. Once you understand what tools can actually do in terms of bringing their features to bear in your projects. And of course, if you know if you want to implement machine learning and artificial intelligence, I mean, there's a very direct substitution of thinking done by testers to what you might call thinking done by technologies. Of course, if you understand how you think, then you know how machine learning and AI could potentially help you in the future. So I think there's a benefit there. And the third area is really, you know, what are the skills that I should be looking at in the future? So in like 1 year, 3 years, 5 years, what should I be looking for to what experiences should I be looking for to get under my belt, to understand what I can offer in the future and to improve how I can make a better testing offering in the future. So those are 3 areas. Now, of course, there are many other things I could talk about, and there are some that directly I could have added to this conversation, to this presentation. And one is, how much testing is enough? You know, the big ultimate question for testers, obviously. Another one is getting the support of stakeholders. And there are other questions as well that we could address. So what I've found is that by understanding how you think as a tester, you have a deeper and better insight as to some of these problems that we have to tackle in our everyday projects, whether we are the tester on the Agile team, or we are the test manager of a team of 100 testers in a very large project. I think the thinking processes are the same. We think differently, we have different thoughts, but the thinking process is very similar. This is my thesis, if you like. So let's move on and just make a start. So I want to talk about what I call a new model for testing. It's not new, it's some years old now, but I'm stuck with the label. Maybe it's marketing, good marketing to call it new. It never goes old, I suppose. But I want to do this. I want to ask you to free your mind, if you like, to clear away all the clutter that gets in the way of your thinking when you're testing. So the way I'm going to present this is I'm going to suggest there are some aspects of our jobs that I don't care about, you know, and I'm going to suggest, and let me just say it, okay? So for the next few minutes, I'm going to suggest this, that I don't care whether you document your tests or not. Documentation has nothing to do with testing. It's a logistical task which you may or may not have to do. It doesn't affect the way you think, okay? It's really important. In some projects, documentation is everything. In others, documentation is very light. Of course it is. But documentation is not testing. It's a chore for most people. I don't care whether you automate your tests or you run them manually, let's say. That is, they're run by humans. I don't care whether you're operating in an agile environment or waterfall or continuous delivery or the next big thing. I'm going to take that out. That's not relevant to the way I think about what I call this job testing. I don't care what business you're in, you know, what business domain you're in. That's not relevant. That's not testing. I don't care what technology you're using. Technology is really important, but it's not testing. That's a separate challenge. Okay, so logistics is a different thing. I don't care how you're organized, whether you are a test manager of a large team, you are the tester on the team and there is no test manager or anything in between. Organization is not relevant to how you think about the problem of testing. Okay. So let me start from the top of the mountain and make this statement that all testing is exploratory. And I'll justify this as we talk, but if you like, I'm starting from the position with a blank sheet of paper and say, well, how do I test this thing, or this system, this software, this product, whatever it happens to be? I have to start with the position of exploration from end to end, okay? And let me explain it, if you like, from the mountaintop and make this kind of statement. What we do is we explore sources of knowledge, sources of information, and those sources of information could be documentation, could be narrative requirements in the good old-fashioned way. It could be user stories, it could be Gherkin stories, it could be a conversation in front of a whiteboard and some doodles. It could be any of these things. But we also have knowledge of the old system, which might help us understand what the new system should do. And we also have the new system when it's available. That is a source of knowledge for us also. So we have all these sources, and sometimes these sources align perfectly, but very often there are gaps, very often there are contradictions, and very often there's ambiguity as well. So they're not perfect, so we have to deal with that. But what we do is we explore sources of knowledge to build mental models, test models, I'll call them. And what a model is simply our way, our human way of understanding complexity. We build mental models to simplify the problem and to build our understanding. And in everything I say in the next 20 minutes or so, if I use the word model, you could substitute the word understanding. What humans do is they build mental models to build understanding, okay? So we have our sources of knowledge to build test models, and those test models, those models inform our testing. And by inform, what I mean is they don't tell us what to test, but they give us a very clear indication of what we should treat as important in our testing and what we should identify as things to test. So in a very trivial way, you could say a flow chart is a model. It could be a model of the flow of control in some software. And in order to test that complicated piece of software, we could use the model to trace paths and pick off decisions and decision outcomes to achieve some level of coverage, perhaps, that we can measure as well. So what the test model does is it gives us an insight as to what to test, but without looking at the detail of the software itself, okay? So models abstract the complexity of our systems and allow us to build tests in a more systematic way and a more humane way, let me put it that way. So that's the view from the mountaintop. Next thing I want to say is, okay, let's come halfway down. So if you like, I've got these two modes of operation as a tester. One is exploring. I'm exploring my sources of information. I'm reading documentation. I'm looking at user stories. I'm having conversations with users and developers and other people on the team. I'm going back to my own knowledge and experience, but I also get free of charge my biases and my prejudices as well. So, you know, my own experience, intuition, knowledge, and all that kind of stuff is tainted by my own prejudices and biases. Okay, so you get everything. That's the thing. And so exploring is about trying to make sense of this complexity. And what we do is we build models, test models. So on the left-hand side, you can see that we do this exploring activity. And then what we discover is that at some point we believe we know enough. That is, we've done enough exploring, and you think, I think now I can test. I think my model is adequate. And if you like, I use my judgment to make that call. And if you like, what I do then is I have my models, and they may be written down, they may be just in my head. I don't care. That's logistics. That's not relevant to me. I use my model to derive tests, and I do some testing, let's say. So when I do that testing, which is a very familiar activity for all of you, I'm sure, sometimes I discover my models aren't adequate. It's like, oh, it's a bit more complicated than I thought. The requirements are clear, but the system is built in a way that makes me now understand this is a more complex problem. So maybe my models aren't adequate. So maybe I have to go back to talk to users, and we've all done this to get some clarification. Or maybe we discover something that is like, looks like a bug, but is it a bug, or is that how it should work? Or what does the user think? And we have this kind of conversation again back at the beginning. So we have this kind of notion of judgment in the center. We do exploring on the left, but we want to move on to the right as soon as we can and get the job finished. Okay, sometimes we get bogged down, if you like, on the left. So as a little side note, the question might arise, well, do developers explore the same way? I think the answer is yes, because they have exactly the same sources as we have, usually. Same people, same documents, same old system, blah, blah, blah. And they have to build a model in order to solve the problem that they've been tasked with. So they do modeling in they have a modeling challenge, but they build different models to us as testers. So there's more to say on that. Now what I want to do is just like come down and dirty and get into the detail, but I'm going to do this really very quickly because I want to get onto the interesting stuff, if you like. So the first thing is we have this notion of exploring, we inquire, and inquiring is basically reading documentation, interviewing people, listening to their answers, looking at the old system, exploring the new system, and so on. So exploration is about asking questions and inquiring initially to gather data. And we build models in order to understand that. That's the modeling activity. And when we have a model and we think we understand what the system should do, we can make predictions, because now we can say, if I enter A, B, and C, then D, E, and F should be outputs or activities from the system. So I can make predictions, and that's part of the exploration, exploring what the possibilities are with our system. But very often we discover anomalies in requirements or the old system or whatever, and we can use that predictive ability to offer examples to our sources, to go and challenge users and say, well, look, if I enter A, B, and C, should it output D, E, and F? And that's the question. And the user might say what? They might say that's perfect. They might say, how did you get that idea? Well, I read the requirement. And that's, and suddenly you're exposing schisms in people's thinking. And so challenging is part of the testing process to get to the bottom of requirements and to understand and get clarity, in effect. So let's push that to the left. And I've got my models. Well, my models, I can use those to inform my testing. So if I have a mental model, I can start using that mental model or a documented model to derive tests. I can apply those tests to the system under test. And I use the word applying because I don't want to get kind of drawn into the testing versus checking debate. Applying simply means the test is applied either using a tool, some technology, or it's a human being doing the same actions. Now, of course, you lose a lot if you use tools compared with human beings. You lose the human observer. But in terms of applying the test, entering data, observing outputs, and doing comparisons with expectations, that's what applying is. Now, when we apply those tests, we need to interpret the meaning. If we have 100 passes, well, what does that mean? If we have 100 failures, what does that mean? So interpretation is usually a human activity. We still have to do that. Now, if we do discover an anomaly, well, we might log that as a bug, revise the system, update the system, and then go through the applying and interpreting cycle again. That's not really part of the model, but that's where, if you like, the bug logging comes in. Now, of course, when we run our tests, we want to share that knowledge, the outcome of those tests, with someone else. We do our reporting. And at that point, we might say our job is done. But very often what happens is our models aren't perfect. We discover what we think are anomalies are actually misunderstandings about the requirements. Maybe our model is wrong. Our understanding of the requirement is wrong. That's possible. We do that quite often. But there might also be an issue where the model itself, the requirement itself is wrong. We've discovered an anomaly in the thinking of our users. And we have to go back and demonstrate using examples, using the real new system to say, look, this is what the new system is doing. Is this correct? Is this what you actually want? Because we've followed all the process and the requirements and so on and so forth. This is the outcome. And it might be that you have to rethink some of the requirements. It's possible that that happens. Very occasionally, you might have a complete redesign of a system because the whole fundamental of the system is undermined by the poor thinking that's happened at the beginning. So testing can discover these schisms in our projects. That's one of the things that we do. Now, when you glue the two halves together, you get this kind of shape here. And all I've done is join dots between the two halves of the model. If you want to see more, there's an Agile Testing Days webinar, which is a longer explanation and probably a slightly, where I speak a bit more slowly, perhaps. But what is this? What have I just shown you? What I've done is try to identify the different modes or states of thinking as we go through the process from sources of knowledge on the left to testing the system under test at the end, with these kind of feedback loops or these like detours, you might call them. And every one of these activities is a thinking activity. It's not a physical activity. But inquiring, for example, on the left at the start, might be having a meeting with users to discuss a requirement. It might be reading a requirements document, reviewing a requirements document. It might be looking at Gherkin stories, which might be used in Cucumber or SpecFlow as the tools that we use in a behavior-driven development environment. Every thinking activity has all the logistical activities behind it, but the thinking activity is, in its purest sense, has a goal, which is to gather. Inquiring is to gather information to build a mental model. Okay, so every one of these ING activities, let's say, has some logistics behind it to make it all work in our projects. But every project is unique. Okay, that's the point. So every thinking activity has associated real activities, logistics, if you like. Now, one thing that you realize very quickly is actually your brain can work on multiple processes at once. That's kind of cute, in that we could, in the same 5 minutes, be looking at asking questions and inquiring, or we could be running tests, or we could be doing interpretation, or we could be feeding back and challenging our sources of knowledge. They're not stages of testing, they are modes of thinking. So they're driven by events. Okay, so it's a much more dynamic kind of process in our heads than a staged event, like waterfall stage. So for every feature or requirement in an iteration in an Agile project, we might be thinking differently. That is, every feature might have different status. So to talk of stages of testing, stages of this, stages of that, it's almost meaningless because everything's at different statuses. So what I want to suggest is that our brain is capable of working in a much more dynamic and event-driven kind of context than a staged process. Okay, so that's kind of what I'm going to posit as a thought to bear in mind. So I want to explore some of what I've called big problems, big challenges. These are the kind of the typical things that come up, and there are many of these. Okay, so I've just cherry picked some which I think are easy to understand and actually might be the most useful right now. And the first one is about continuous delivery. And many companies are thinking much more seriously about moving from monthly, from 9 monthly projects to monthly iterations to fortnightly iterations to, hold on, maybe we can speed it up completely and take advantage of this idea of continuous delivery. Because we all want to be like Google, don't we? Now, this is a problem for testers because we have this challenge of having to deal with a very rapidly escalating and very dynamic kind of process. It's basically continuous delivery of smaller, tightly scoped iterations of small amounts of functionality. So I think very often testers get caught up in this kind of maelstrom of not knowing exactly how to react to this speed of activity. And it's not because they're stupid, it's because their thinking is like a staged kind of thinking. They're still thinking of waterfall and maybe the way that certification schemes have taught testing historically, which I think has its place, but it holds us back if we're looking at more dynamic environments. Now, when you look at continuous delivery, you get these kind of images up, and this is just like a random selection, but by and large, the most common is this kind of infinite loop. So I hope you're kind of familiar with this, but essentially it's a series of activities which you repeat again and again and again. On the left is kind of the plan, build, and test kind of activities. On the right, it's the deploy into, release, deploy, operate in production, and monitor. And then we use the logs of our production systems to help plan the next iteration, perhaps. But I have a problem with this. Because if you unwind that infinite loop, it's a staged process, and you think, well, hold on, I thought we were moving away from waterfall. That's just waterfall in a nutshell, in a smaller iteration. What's changed? And so the problem I have is that the way continuous delivery is explained very often is it's still a staged thinking, and yet we know from our experience of waterfall that the things that waterfall does badly and that agile is a reaction to are these things here, the things in red, like it's sequential. You can't go out of sequence. You've got to follow one stage with another. And dependencies drive everything. You can't join into a process midway. You've got to go start at the beginning and finish at the end, and so on and so forth. And there's these other things. Testing is always squeezed because it's in one place, and it tends to be towards the end. And there are no feedback loops. It's a staged process. So that thinking won't work in a continuous process. And forgive me that I don't reference this picture, but I picked it up off the internet as an example of testing in continuous delivery. And if you know who drew this, I'd love to recall who I got this from. I can't remember. I have to be honest. But not everybody will do all these test activities. But if you're doing all this stuff, or some of this stuff, or even a little bit of this stuff in a continuous loop kind of, it becomes overwhelming. I mean, you're just so busy running that you forget to stop and think and get your head around how you operate from day to day. It's a really tough thing to do. So I want to suggest that the continuous delivery process is not staged, it's event driven. And remember what I said, that with the thinking process is our brains are comfortable with being event driven. That's kind of how humans operate. We are hunter-gatherers. Our brains are programmed to deal with things going well, things going badly, and things going out of sequence. And that's life, and that's how we are built. So I think our processes should also be event driven in that respect. Now, events could be anything like a failure in a test or in production, or a failure in a deployment, a release, or it could be a human interaction, which suddenly reveals some information that changes people's perspective, that we thought we were here in our projects, but suddenly it turns out we're over here. Well, what do we do next? Now, forget the process, because you've just got to jump from one place to another in your thinking. That's how it works. That's the real world. And it's why very often we get a little bit lost as testers in continuous delivery projects. So here's in a nutshell what I want to suggest that we think about status, and this is like one of the concepts I think that is coming out of this idea is that status isn't where a feature is on a Kanban board. That's completely meaningless. Status is what we're thinking about at the time about this feature, and what can happen is that when we have a little meeting, the three amigos, the user might say, I'm done, I've defined the feature, I'm just waiting for the software so I can have a play with it and see whether it works. I'm finished. And the developer might say, well, I'm writing code, I'm running my tests, I'm making progress, this, that, and the other. And the tester might say, well, wait a minute, I've still got some queries on the requirement itself. I've got some examples of where the requirements are inconsistent or ambiguous. How can you be building code while I've got this problem? And so the three people around the table are in different places. The status for each of them, for each of their perspectives, is different. So there's something wrong here. And that's the value of testers in that we trigger these pauses, you might call it retrospective almost, to say, well, how did we get here? Where are we? What do we do next? And so this is a very dynamic thing. You're not looking at a process end to end. You're looking at where people are thinking right here, right now. And that's how we should be thinking about process in our more continuous delivery environments. And I should say, in any environment, not just continuous delivery, it's agile or waterfall, we always get these anomalies cropping up, these events which mess things up. So what we think about a feature is its status. And so when we ask what the status is, we ask really, what are you thinking about? Where are you, for example, in this model as a tester? You know, are you inquiring, informing, applying, interpreting? What are you doing right now with this feature? And so we have to compare our thinking positions with others, and then we act. So that's continuous delivery. But I would say that way of approaching process is common to all processes, all approaches. And there's no such thing as a textbook agile, textbook waterfall, textbook continuous delivery. I mean, there are textbooks, but everyone does variations. That's the point. And so you have to be able to cope with these variations, these events, let's call them. So now I want to talk about tools briefly, and talk a little bit about test automation, but also a little bit about what testers need from machine learning and AI. And this is a whole talk in itself I've done recently. So I'm condensing about 45 minutes into about 4 minutes now. So apologies for that. The first thing I want to say is this concept of test automation misleads. Test automation is not what it says on the tin. We don't automate testing. Okay, we're automating one aspect of testing. It misleads as a label because test automation only focuses on what I might suggest is one activity out of 10 in our thinking process. Okay, so test execution automation does not help us with modeling or asking questions of users or challenging users or refining and predicting. It doesn't help with any of those things. It helps with one activity out of 10. So the question, will robots replace testers? Well, certainly not yet. Not if we're just focusing on test execution automation. That's just not a start. That's a non-starter. Okay. So I just want to get that out of the way. So don't think that test automation is like, oh, that's testers being replaced by tools. No, not going to happen. But in order to take advantage of machine learning and artificial intelligence to support some of our thinking activities, which is essentially what we want tools to do, that would be really wonderful if it did do that. We know we've got two styles. I mean, there are many styles, so I'm generalizing, of course. There are different styles, but I'm going to look at structured or waterfall or stage testing versus exploratory testing. And the good points of structured, waterfall, staged, you can see, and this is debatable, I understand. Not everybody does it this way and gets these benefits in the same way. And exploratory, by the same token, has its good side as well. But the advocates of exploratory testing, the advocates of waterfall, in attempting to see both sides, the positives and negatives, might take pot shots at the other side and say, well, look, we're systematic, transparent, documented, reviewable, blah, blah, blah. Exploratory testing isn't repeatable, not easily automated. There's very little documentation. It's hard to manage, blah, 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 blah. And so there are these arguments about which is best. From the point of view of my thinking, the new model idea is this is all logistics, okay? This is all stuff that's really important, but it's not about testing. It's about the mechanics of getting the job done. And so what I think we want from tools is we want the best of structure. We want the best of what is usually called exploratory testing, but bearing in mind, I think all testing is exploratory. So if we can take, the top, the black bullet points and try and take advantage of those with our newer technology, emerging technologies in the testing space, I think we'll make some good progress. So in order to gain the best from these emerging technologies, we have to look at the best of structured and exploratory testing. We need a hybrid, okay, as always. We need to make some compromises. We need the best of both worlds, perhaps. So the first thing I want to say is, again, going back to the new model idea, on the left is all about exploration. We need exploration support. So we need tools that will capture models in real time. So as we explore the system under test, for example, and we navigate through that system, I want a tool to be listening and watching and hearing everything I'm doing against the new system, capturing it and building a model. Because if it's tracing, if I'm tracing paths through a system and the tool in the background can see the actions that lead to those paths and the if you like, the nodes and the network on these paths, how they are defined, because I might be talking to my tool as well as I test or as I explore, well, a model can be built, and it would be a model of the valid paths through a system. And it might also model some of the error loops where I put in incorrect data and it's rejected, maybe. But I want a tool that can replay what I've done, and it might not replay as an execution of the system. It might replay it as a narrative of where I've been and where I've visited. Now that model is a starting point where I could refine that model either to explore other bits of the system, because I can see where I've been now and I want to go to other places and do other things. But I can also ask the tool to look at combinations and permutations of the things it's seen to look at other potential paths through the system. Now, of course, it's more complicated than just generating random, well, semi-random paths through the system. But I think we should be moving away from writing code to code tests to have a surveying metaphor. We survey the system, we explore it, in effect. We survey it and capture what we discover in a way that can be used by our tools and can be used by testers, whether we're testing manually, i.e. humans are running tests, or the tool is going to run some tests. That model will allow us to report our actual tests against a model. And so we'll be able to come up with more reasonable measures of coverage that have meaning. Now, of course, it's an indirect measure of thoroughness, of course, but it's a helpful thing to know that where you've been and where you haven't been. And that's what models are about in this respect. So surveying is really about capturing a model. And I believe we don't need machine learning and AI to do this. I mean, we could have done this 10 years ago, I think. And that's why I'm disappointed in the tools industry, that they haven't really focused on this, because this is the most valuable part of the testing process, almost the exploration side. The test execution side is kind of a mechanical process. Yeah, that's low-hanging fruit for tools. But the information required for scripting is in the models that we capture. That's what surveying does. Now, if you like, one way of looking at this would be that humans make the early maps, but the tools follow the trails that we've mapped. Okay, so that's kind of the thing. So all the intellectual effort of the testers is to build the map. And then the tools, with some guidance from the humans and maybe some configuration, some criteria that we define, the tools can follow those trails to run regression tests, let's say. So we probably will be doing manual testing for all time, but tools can do all the regression testing. That's the way it should be, I think. So I want to suggest that the way we look at technologies, the architecture should be something like the tools that developers use. So they have an interactive development environment. Well, we need, as testers, an interactive test environment. So I want a tool which will allow me to press a button and say, okay, I'm in, let's call it surveying mode. I go and explore the system on a test. and the tool is building a model in the background. I want a mode where I can go back to that model and refine it manually, or re-record aspects of my exploration and capture that in the model because I've obviously missed some stuff. Okay, I want to be able to map that model to back-end data because the tool will be monitoring all the messages into and out of the client, perhaps the mobile or the PC I'm using to interact with the system at the back end. So I want an interaction with the tool and the back-end data to see what data is actually connected with the exploration I've done. I want to run tests manually and have the tool capture the results and log them and so on and so forth, and measure coverage and give me pretty pictures and all that kind of stuff. And then when I'm ready, I want an unattended mode in that I want to run tests without supervision. So now you can, these things already exist in that people use existing tools to code tests, to record tests, to debug tests, to whatever. I'm just trying to suggest that we can be much more sophisticated, okay? The tools are basically programming environments with a very special purpose. And we need to move away from that and make them into tester tools, not developer tools that have a special purpose. And that's really not very helpful to us, I don't think. So the test automation problem becomes a modeling problem more than anything else, okay? That's kind of the goal, okay? We don't want to be looking at code particularly. And that's a long-term, we've always thought that, but the tool vendors have, until very recently, not paid much attention to that requirement. I want to talk about testing skills very quickly, because once you understand, or this is my belief, that once you understand the thought processes that testers go through, and then you recognize for each thought process there are some logistical skills behind it, you can then understand how skills have to be orchestrated, if you like, in order to do our job, okay? And we can also identify the skills that we have and that we are lacking as well. So a couple of years ago, I was working with a group of QA managers in Ireland, about 20 of them, I think, to identify, I call it a skills inventory, just a list of areas that I think we should pay more attention to, or rather that the QA managers thought we should pay more attention to. And I prompted them a little bit, but this is their list, not mine. And you can see from the red items, these are things that you wouldn't normally expect to see on a, for example, a testing certificate course. So stuff like adapting testing. So the first thing you have to do when you come to a new project is whatever you've known in the past about testing is going to have to be adapted for this new project. So that's got to be part of your skill set. There's no question. So to come at it and say, well, I do testing this way, and then the project says, well, we don't work that way. What do? You've got to know how to adapt. And so adapting testing is this is a rough alphabetical order, I should say, not in terms of importance, but adapting testing has got to be part of the syllabus, if you like, of stuff that you need to understand and have skills in. And the same goes for assertiveness, because then you have to do a bit of negotiation. Like, I want to offer this, and then the test manager, project manager or product manager says, well, that's not enough. We haven't got, we need more from you. And then you can say, well, look, this is what it will cost you. And you have to defend maybe an estimate or a budget or a way of working to give them what they need. And there might be some negotiation required. There's definitely collaboration, there's definitely communication, there's definitely critical thinking, and so on and so forth. There's nothing on here that you would say, well, that's not a very helpful skill. Well, we all know that on occasion we have to take the human, interpersonal, professional skills a step further, okay? And overall, I can't remember the numbers, but it's about 40 items in this list. And a lot of teams nowadays are sharing information through coaching and mentoring. So coaching and mentoring should be part of our skill set, either as to be a coachee or a mentee, I think is that the right word, but also to, if you are the tester in an agile team, you are going to find yourself coaching the developers to do a little bit more, perhaps, and maybe some assertiveness involved as well. But you're trying to get people to take ownership and responsibility for their aspects in the project. So these are the kind of the skills that I think we should pay much more attention to. I've drafted a kind of a structure to a training regime, but it's not training. It's a learning and development regime. So for every hour in a classroom, there might be 1 to 2 hours of local mentoring or coaching. So it's a much more substantial thing than just a 3-day class. It's not a 3-day. There's about 7 days worth of teaching required here, plus, maybe 7 to 14 days worth of background exploratory work done by the testers themselves, let's say. So it's a learning and development scheme, not just a classroom lectures. So that's, I think, where we are headed. Okay, and whether the certification schemes go in this direction, I don't know, I can't say, but I think this is kind of where we should be going. So to close, I think the world we're moving into is one of more event-driven, continuous everything approaches. It seems like that's the general direction of movement for most organizations. Everyone who wants to move towards more agile, more dynamic development approaches. And I think agile tends towards continuous delivery in order to gain the benefits of using all the clever tools in production to give us insights as to what we should do next in our projects. So I think that's the general trend. So we have to change our thinking. And if we understand how we think about testing, we have a little better insight as to the changes we make to adopt different approaches, different logistical approaches. So approaches should be based on flexible thought processes, on the way we think, not on inflexible logistics. And one of the logistics is the process. Waterfall stage processes don't work in dynamic environments. Testing is distributed. By that, I mean, it might be distributed geographically, but it's distributed across teams now. So the tester doesn't own testing anymore. We're like the first among many in terms of the testers, in that, yes, testers do testing, but they're also coaches to users and developers to help them do a better job of the testing they do. Now, to make all that work, we need a broader set of thinking, business, and personal skills. And I've shown you the list and so on and so forth. If you want to know more about what I'm doing in that area, just get in touch. But we have to move away from just classroom training, which is forgotten the day after, okay, and move closer towards a more learning and development kind of approach, which is what our businesses do all the time. But IT, as usual, is slow to pick up on the common sense things that our businesses do. So we need the logistics of implementing the support for our testers to improve their skills right across these very wide set of skills. And I think with that, I am done. And at the risk of having overrun by a minute or two, I'll hand over to Debbie, I think, if you're still there. Thank you.
Hi, Paul. Well, thinking your way out of very relevant, very real-world problems, and some, as usual, from you, some real insight and pragmatic advice and perhaps some solutions there. And we are a little bit close to time up, I'm afraid, and I have got several questions. Let's see if we can answer a couple. Hi, Kimo. It's lovely to see you here. He asked, could you list 3 most important skills for future testers, please, Paul?
Well, I think if you think about the model, okay, the picture I've shown you, there's an awful lot of communication required on the left-hand side. That is on the collaboration side. So communication skills, asking good questions, being a good listener, that kind of thing. That's one skill. Another one is the whole collaboration aspect and understanding what it means to collaborate. And, again, I'm not going to define it, but I think collaboration is increasingly important. You've got to be a good member of a team as a collaborator. I think the third one is, I'm going to say thinking. Your thinking has to improve. So system thinking, critical thinking, and understanding what you think about when you test. So, I say my model, but I think that should help you about what you think about. And those thinking skills, I think, are more critical. I think testing is done by people's brains, not by their hands and feet and whatever else, other pieces of anatomy. So those are the 3 areas, I think, rather than skills, I'd say.
Paul, I'm just going to say quickly, we've got a lot of thank yous to you here. Clarita says, awesome talk. Thanks a lot. Mike Sunman has said, thanks, Paul. Enjoy the presentation. Lots of lovely responses to what you've been saying. I'll ask one more question very, very quickly. It's something that goes around in circles, I think. Do you have an answer to how much testing is enough?
I've got some training material. I mean, just a little plug for myself is last year I ran a thing called Leadership in Test as a series of webinars, but I recorded them all and I've broken them up into teaching sessions. Just get in touch if you're interested. I can point you at the website. You can take a look. But that's more for individuals in teams who are the testers who have to lead locally, but also test managers and test leads as well. So there's a certain amount of material in there embedded, but it's a bigger scheme, if you like.
Oh, perfect. And hopefully, Clarita Ramos-Gonzalez, that helps to answer some of your question also. We're out of time, I'm afraid. Paul, again, huge thank you to you. It's a pleasure as always. You started the presentation with free your mind and clear the clutter. My mind is buzzing, and I'm sure that the rest of you will be also.
Too much to present.
A lot in their mind. Message here from Ina Unday, a wonderful breakdown of the cognitive process involved in testing. Couldn't agree more, and a great way to end the session. Thank you again, Paul.
Thank you. Take care.
Bye-bye. Bye-bye.